Hey, eighth graders, we are looking at two-way tables today, and they can be a little complicated. So let's just go through these two-way tables together. So we're going to be looking at marginal probabilities, joint probabilities, and conditional probabilities. All right, so here we have a two-way table. So it says the table shows the results of a survey of students by gender and by what kind of pants or bottoms they were wearing. So the first thing we would do is fill in these totals. So a total of 12 students had on shorts, a total of 98 students had on pants, a total of 60 students were boys, and 50 students were girls, which gives us a total of 110 students. So if you add this way and this way, you should get the same total, 110. So marginal frequencies is entries in the total row and the total column for a two-way table. To find the percentage, you would put the total for the category out of everyone, the grand total. This is known as relative frequency. It is given by dividing the frequency for a category by the sum of all frequencies. You can use it, you can show that information through percentages or decimals. Use the table above to find the marginal percentages. What percentage of those surveyed were wearing shorts? So of all the students surveyed, what was the percentage of those wearing shorts? Well, the total number of students wearing shorts was 12 out of 110. So we would write 12 out of 110. And when we divide that, so I get 12 divided by 110. I'm showing that about 11%. So I got 0.109, which would be about 11%. So 11% of those surveyed were wearing shorts. All right, so let's look at all these questions. What is the probability that a child selected, hold on, whoops. All right, so of the grand total, what is the probability that the child selected is a boy? Well, how many total boys were there? Total of 34 boys out of 68. And so, of course, that is 50% or 0.5. What is the probability that a child selected is a car rider? So they're all children, right? But the car riders, there's a total of 28 of them. So there's 28 car riders out of all the students, and 28 divided by 68 is about 41% or about 0.41, which is about 41%. What's the probability that a child selected is a girl? Well, how many girls are there? There's a total of 34 girls out of 68, which is half of them, right? Which is 50% of them. And then what is the probability that a child selected is a bus rider? So how many bus riders? We had 40 bus riders out of 68 bus riders, and that would be about 59% of them. 59% were car riders, or excuse me, bus riders. All right, now you'll also have to look at marginal relative frequency. So relative frequency means they want the information on your table as a decimal, all right? So if you're talking about marginal frequencies, we're talking about out of the grand total. Well, the grand total, that would be 100% of the people surveyed, right? So 100% as a decimal is 1. Okay, so how many of the grand total were boys? Well, half of them, wasn't it? Half of the people surveyed were boys, and that means half of the people surveyed were girls, and that made up the 100%. Well, out of the total number of bus riders, we had 40 out of the grand total. So 40 out of 68 is about 0.59. And then to get this total, we could just subtract 0.59 from 1, or we could do 28 over 68, and we would get 0.41. All right, so now we're still talking about a grand total of 1. So now we want to know how many of the total students, how many were boys, or what fraction or what decimal of them were boys and bus riders. So we would have 24 out of 68. So about 35% of them are 0.35. 16 out of the grand total were girls and bus riders. So 16 out of 68 is 0.24. And that is equal to 0.59, isn't it? And then 10 out of 68 is about 0.15. And 18 out of 68 is 0.26. And so that's how you do marginal relative frequency. So relative frequency means you need some decimals. All right, now when we're talking about joint frequencies, that's the entries in the body of a two-way frequency table. To find the percent, you would find the cell that two things are happening in, all right? So what you're looking for is the word and. Okay, that means there's two things going on. For example, use the table above to find the joint percentage. What percent of those surveyed were boys and wearing shorts? Well, that means you're looking at this section. When it's talking about joint frequencies, you're looking at the middle section of your two-way table. So of the people that were boys, these people right here, and were wearing shorts is 10. So we had 10 out of 110. So 10 out of 110 was about 9%. All right. So then it says, what is the probability that a child selected is a boy and a bus rider? Well, boys and bus riders, we're looking at this section, 24 out of 68. So 24 out of 68 is about 35%. All right, what else? What is the probability that a child selected is a car rider and a boy? All right, you guys go ahead and answer those. Pause your video, answer these, and then come back and check. All right, a car rider and a boy. A car rider and a boy would be 10 out of 68. 10 out of 68 is about 15%. A child that is selected is a girl and a bus rider. So girls and bus riders are 16 out of 68. So about 24%. And then a child selected is a car rider and a girl. So we have 18 out of 68, and 18 out of 68 is 26%. 26%. All right. And then we talked about, actually, one of the things they wanted us to look at is strong association. So when we looked at this, this just came to me. All right, so when you look at this data right here, is there a really strong association between gender and whether you're a bus rider or a car rider? There's not really. The highest marginal frequency is that there are more bus riders than car riders, right? More bus riders than car riders. Boys prefer to ride the bus, according to this column right here. Boys prefer to ride the bus. But is there a strong association with girls? And either way, they get to school? No, it's almost exactly the same. So if one of these would be like 0.75, you would say that's a strong correlation or a strong association. But for these, the numbers aren't very significant one way or another. So we couldn't make a lot of definitive statements based on the information we just looked at. All right. So what about conditional frequencies? That means that you're looking at something like only boys or only girls, or those people that only wore shorts. Of the people that wore shorts, what percent of them were boys. You would only look at the total of the students wearing shorts. That would be your denominator. All right, so there's giving you some information, but it's conditional. It depends on the number of boys. How we get the number of boys depends on if those people are wearing shorts or something like that. Okay, we'll look at some examples together. All right, so use the table below to find the conditional percentages. So look at this first half of this statement. Knowing that the person has on shorts, so we're only talking about 12 people, what is the percentage of boys? Well, of the people wearing shorts, 10 of them have on shorts. So 10 out of 12 is 83%. 83% of the people wearing shorts are boys. That's conditional. We're not talking about the whole table, right? We're only talking about the people wearing shorts. All right, so what about these? Nope, I went too far. What is the probability that a boy selected, so we're only talking about boys, boy selected is a car rider. Excuse me, I can't read. A bus rider. Well, of the boys, there's 24 bus riders. So 24 out of 34 is about 71% of the boys are bus riders. What is the probability that a girl selected, so only girls, we're only talking about girls. So of the girls, how many, or what's the percentage that are car riders? Well, there's 18 car riders that are girls. So 18 out of 34. So about 53% of the girls are car riders. What is the probability that a car rider selected? So we're only talking about car riders this time. Only car riders. So we're only talking about 28 people. Of those 28 people, how many is a girl? So there's 18 out of 28. So look, those criteria are the same, but it depends on out of what category. So basically the first, mostly, not always, but the first description is our total, but depending on if they, say it weird, sometimes you got to read it carefully. You got to read it carefully every time. All right, so about 64% of car riders are girls. And then what is the probability that a bus rider, so how many bus riders we got? 40 bus riders. And how of that 40, how many are boys? 24. So more than 50%, right? So 60% actually. 60% of the bus riders are boys. Now, conditional relative frequency, that means based on something. It depends on, it's conditional on, this time it's gender. So this time we're not really interested in the grand total of boys and girls. If we're looking at conditional relative frequency for gender, that means we're looking at just the boys columns. Well, if we talk about all the boys, we're talking about 100% of them, which is equal to 1, right? Next, we'll look at all the girls. Well, all the girls is 100% of them. So now we want to think of our boys. If we're talking about all of our boys, we want to know of the boys, what percentage are car riders? Well, there's 24 out of 34. So that means 71% of the boys are bus riders. And then we're going to look at, okay, of just the boys, so 34, 10 are car riders. So 10 of 34 is 29%. Okay, so then the girls makes up its own column. So 34 is 100%. So this is our grand total of girls also, right? So we're going to think of for the car riders, 18 out of 34. So 53% of the girls are car riders, which means 47% have to be bus riders of the girls. So that's the difference in marginal relative frequency and conditional marginal frequency. All right, now these questions are all kind of mixed up, the conditional, joint, and marginal. So you have to read them carefully. What is the probability that a child selected is an 8th grader? Well, all of these students represent students, right? First of all, before I answer these questions, let's go ahead and find up our totals. So 18 and 12 is 30, 34. 20 and 12 is 32, 36. So 34 and 36 are what? What is that? 70. So we have 24 here. We have 24 here. Oops, what am I doing? So 24, 24, 18 plus 8, 9, 10, 11, 12, 22, 8, 9, 10. Yep, so that's 70. All right, what is the probability that a child, so all of the students on this graph or table are children. So the only criteria we have is 8th graders. All these kids, what is the probability that they are 8th graders? Well, there's 22 8th graders out of how many students? So 22 out of 70. So 22 out of 70 is about 31% of them. All right, what's the probability that a child selected attended a basketball game? So once again, they're all children, so we're only looking at the total that attended a basketball game. So 34 attended a basketball game out of 70. 34 out of 70. So that's marginal. That's marginal frequency, right? What is the probability that a child selected is a 6th grader and attended a basketball game? So that tells us when we see the word and, we're looking at this section out of the total. So a child selected is a 6th grader and attended a basketball game. So we had 4 out of 70. 4 out of 70, not very many. So only about 6%. 6% of these students met those 2 criteria. That's joint frequency. What's the probability that a 6th grader selected? So we're talking about only 6th graders. We selected only a 6th grader. So this time we're talking about conditional. Of those 24 6th graders selected, how many of those 24 did not attend the game? They did not attend it. 20 of the 6th graders selected did not attend the game. 20 out of 24 is 83%. So of the 6th graders selected, 83% of them did not attend the game. Hopefully you guys got those right. All right, so here are some questions. Now, I do give you some slides with all the answers on there. I want you guys to try those on your own. But first, let's look at these. So our total number of students was 80. And so 39 and 41 is 80. 31, 28, and what is 80? Let's see. 31 plus 28 is equal to 59. So our missing number right here is 21. All right, and we got to make sure these numbers add up to 39 and these numbers end up with 31. So if we take 15 from 31, we get 16. 16 plus 17 plus what is 41? 8, right? And then 28 minus 17 is 11. And then 15 plus 11 is 26. And 26 from 39 is 13. And then does 13 plus 8 equal 21? All right, I think we got it. All right, what percent studied German? Well, of all these are all students. What percent of all these students studied German? Well, 28 out of 80. So that's marginal, right? So 35% of them studied German. What percent studied German and were male? That means we're looking at this section out of our total. Joint. So we're looking at the male and how many studied German. 17 out of 80. 17 out of 80. So about 21%. All right, and then the last one, knowing the person is male, all right, we're only talking about these 41 male students. This is conditional. Knowing the person is male, 41 males, what percent studied German? Well, 17 out of those 41 studied German. 17 out of 41, which is about 41%. All right, I think we got it. All right, now the next two slides, you have your questions. I've given you the answers. I want to make sure you guys know how to get those answers. So quiz yourself. So do those few problems, those slides. And then when you have your Delta Math example, I just wanted to just show you that the first thing hopefully you notice is that there's no totals column. So if I were you, the first thing I would do is write down the total. So 9, 10, 11, 17, and that would be 28. So here we have 13 and 15, right? These are our totals. And then you're going to answer the questions. What is the probability that a student chosen randomly from the class, so all of these people represent students, does not have a dog or a cat? So does not have a dog, does not have a cat. That is kind of like an and question. It says or. So we could rephrase it. Does not have a dog and does not have a cat. So we're looking at joint frequency. So 11 out of 28. I'm not sure on Delta Math, you're either going to leave it in fraction form or you're going to write it as a decimal. I'm not sure. It'll give you the directions. All right. And then one more to look at. We would, like I said, write in those totals. All right. So how many students have a brother or a sister? All right. What is the probability that a student has a brother given that they do not have a sister? All right. So that is a condition. So this is one, they have their wording really kind of strange. That's why I wanted to point it out to you. So based on the criteria that, or the condition that this person does not have a teacher. So how many people are we talking about? Have it, does a teacher, does not have a student. There I go again. Does not have a sister. So we're talking about 10 people. The condition is the person does not have a sister. What's the probability that that student has a brother? Well, 7 out of 10 is going to be the answer, 70% or 0.7. Okay, based on the criteria that the person does not have a sister, what's the probability that the student also does not have a brother? Okay, all right, so hopefully that helped. Get through your lesson. Make sure it's a little challenging, but you guys are honors algebra students, so I know that you guys can do it. I believe in you. All right, so if you need me, reach out to me, and I believe we are Zooming. What day are we Zooming? I don't even know if I posted it yet, but anyway, we'll get together later in the week and Zoom, and if you need me before then, just send me a message. All right, guys, have a good week, and I will see you soon.